Planet Earth, vast and blue, 70% covered by oceans, a magnificent water world. Yet we face a stark reality. We thirst for fresh water, water that flows from rivers, water that collects in lakes, water that falls as rain. Ocean water, despite its abundance, is not a direct source. Why? The answer lies in the nature of salt. Ocean water is salty, very salty. The saltiness of the ocean is something we can taste immediately if we accidentally get a mouthful while swimming. But why exactly is it so salty? About 3.5% salt, in fact. This means that in every liter of seawater there are approximately 35 grams of dissolved salts, primarily sodium chloride. This salinity is far too high for our bodies to process. Our bodies are designed to handle only a small amount of salt, and seawater exceeds this limit by a large margin. When we drink salt water, our cells lose water. This happens because the high salt concentration in seawater draws water out of our cells, leading to dehydration. This is due to osmosis. Osmosis is a fundamental biological process that governs the movement of water in and out of our cells. Osmosis is the movement of water across a membrane. It moves from an area of low salt concentration to an area of high salt concentration, trying to balance the salt levels on both sides of the membrane. It moves from an area of low salt concentration to an area of high salt concentration. This means that drinking seawater actually causes our bodies to lose more water than we gain. Drinking seawater actually dehydrates us. Instead of quenching our thirst, it makes us even more thirsty and can lead to severe dehydration. Our kidneys play a crucial role. They are responsible for filtering waste products from our blood and maintaining the balance of fluids in our bodies. They filter waste products from our blood. This includes excess salts, which are excreted in our urine. They also regulate the balance of salt and water in our bodies. When we consume too much salt, our kidneys have to work overtime to remove the excess. High salt intake forces our kidneys to work harder. This can strain them and lead to long-term health issues. If we consume too much salt, our kidneys cannot cope. Over time, this can cause damage to these vital organs. This can lead to severe health problems. Chronic kidney disease, high blood pressure, and even kidney failure can result from excessive salt consumption. In extreme cases, it can even be fatal. Therefore, it's crucial to understand why our bodies say no to seawater and to respect the limits of our body's ability to process salt. Desalination offers a potential solution. This technology removes salt from seawater. It makes it suitable for drinking and other uses. There are two main methods of desalination. Thermal desalination uses heat to evaporate water. The salt is left behind. Membrane desalination uses special membranes. These membranes separate salt from water. Desalination plants are becoming more common. They are particularly important in arid regions. Places like the Middle East rely heavily on desalination. It provides a vital source of fresh water for their populations. However, desalination is not without its challenges. Section 4. The environmental price tag of turning tides. Desalination is energy intensive. It requires a significant amount of power. This can contribute to greenhouse gas emissions, especially if the energy source is fossil fuels. The process also produces a byproduct brine. Brine is highly concentrated salt water. Disposing of brine responsibly is crucial. If released back into the ocean, brine can harm marine life. It can disrupt delicate ecosystems. Scientists are exploring ways to manage brine effectively. This includes using it for other purposes, for example in the production of salt or minerals. Section 5. Innovation and the quest for sustainable solutions. Technological advancements offer hope for a more sustainable future. As the global population continues to grow, the demand for fresh water increases, making innovative solutions more critical than ever. Scientists are working on more efficient desalination methods. These methods not only aim to provide clean drinking water but also strive to do so in a way that is both cost-effective and environmentally friendly. These methods aim to reduce energy consumption, which is a significant factor in the overall cost and environmental impact of desalination. They also seek to minimize environmental impact by reducing the amount of brine and other byproducts that are released back into the ocean. Renewable energy sources like solar and wind power are being integrated into desalination plants. This integration helps to make the process more sustainable and less reliant on fossil fuels. This helps to reduce their carbon footprint, making desalination a more viable option for the future. Researchers are also exploring new membrane technologies. These advanced membranes are designed to be more efficient and longer-lasting, reducing the need for frequent replacements. These technologies require less energy to operate, which further reduces the overall environmental impact of desalination. They also produce less brine, which is a significant environmental concern. By reducing brine output, these technologies help to protect marine ecosystems. The future of desalination lies in sustainability. By continuing to innovate and improve these technologies, we can ensure a reliable source of fresh water for generations to come. Finding ways to make this technology more environmentally friendly is critical. It is not just about providing water, it's about doing so in a way that preserves our planet for future generations. Section 6. Beyond desalination, safeguarding our freshwater future. While desalination can provide a valuable water source, it is not a standalone solution. Desalination is energy-intensive and can have environmental impacts, such as harming marine life and increasing greenhouse gas emissions. Therefore, it should be part of a broader strategy. Conserving existing freshwater resources remains crucial. This means protecting our rivers, lakes, and aquifers from over-extraction and pollution. Healthy ecosystems are vital for maintaining the natural water cycle. We must reduce water waste in our homes, industries, and agriculture. Simple actions like fixing leaks, using water-efficient appliances, and adopting smart irrigation can make a significant difference. Protecting our rivers, lakes, and groundwater from pollution is essential. This includes reducing the use of harmful chemicals, proper waste disposal, and promoting sustainable farming practices. Sustainable water management practices are key to our future. Communities must come together to implement conservation projects and educate others about the importance of water stewardship. This includes rainwater harvesting and water-efficient irrigation techniques. Collecting rainwater can reduce the demand on freshwater sources, and drip irrigation can significantly cut down water use in agriculture. Every drop of fresh water is precious. It is a finite resource that we must cherish and protect for the well-being of all living creatures. Let us use it wisely. By making conscious choices and adopting sustainable practices, we can ensure that our water resources are preserved for future generations. Let us ensure that future generations inherit a world where thirst is not a defining characteristic. Our planet, our responsibility. Together, we can make a difference and secure a sustainable freshwater future for all.